Hello, algebra students, Mr. Lawrence here, and like it would be anybody else, come on now, we're going to be talking about functions, and you've done functions before. We're not going to actually formally define it algebraically. We will get to that, but we're going to be introducing functions, and I love this because, one, it's real easy, and two, when you figure it out, you're going to feel so blasted intelligent. I mean, some of you, sometimes math makes you feel really stupid. I mean, raise your hand if you've ever felt stupid while doing math. Trust me, I got both my hands up. Yeah, I know, I'm really good at math, but it takes lots and lots of practice to get really good at it. And those of you going, well, I don't want to practice. Well, you want to be good at anything, you got to practice. You don't practice, and you end up like Johnny Manziel. There you go. All right, so here we go. Functions. You did functions in elementary school. Maybe they gave you this function machine, looks something like this, and they gave you a number and they put it in. And then they gave you a rule, and the rule might have been like, I don't know, 2x plus 3. And so then you go, oh, well, that's 2 times 5 plus 3. Now, maybe you didn't use an x. I'm not sure what they use there in elementary school. But you go 2 times 5 and you get 10, and then 10 plus 3 would be 13, and that's what would come out of the function box, right? You remember doing those? Well, we're not going to be using function boxes per se, but what we're going to be doing is we're going to be creating the rules. Yeah, we're going to be creating the rule. We're going to take a set of data, a set of terms, and we're going to create a rule, an algebraic equation, if you will, that tells us where that data came from. This is a pretty powerful tool. So let's take a look at how to do this. Here I have x. These are my x values. This is my input. Okay, this is what goes into the function. All right, f of x. Notice the x is inside the f. The f is the function. This is the output. This is what comes out. Okay, and by examining, when I put 1 into this rule or function, I get 4 out. When I put 2 into the function, 7 comes out. 3 goes in, 10 comes out. 4 goes in, 13 comes out. 5 goes in, 16 comes out. What happens when n goes in? Well, this is going to be where our rule shows up. And I'm probably not going to be able to fit it in this little box here. But that's okay. I'll just write it underneath or off to the side or something like that. On a test or a quiz or homework, I'll make sure I give you enough room to fill it in. All right, now this n is just the nth term. It's an unknown number. See, back in like 6th grade, they gave you a set of numbers, and you said, well, 2, 4, 6, 8, 10. And they said, what are the next 3 numbers? And, you guys are so intelligent that, the average kindergartner could do this. It's almost insulting. It's so simple. And you'd go 12, 14, 16. We're not doing that. We're going to create a rule. I mean, some of you are thinking, hey, I know the rule goes up by 2 every time. Yeah, but that rule doesn't do you any good if I want to know the 1,000th member of this set of data. No, because you'd have to find out the first 999 members, then be able to figure out the 1,000th member. I don't want to do that. No way. I want to create a rule that I could figure out the 50th or the 100th or the 1,000th or the 10 millionth number in the set of data in just a second or two without going through the first set of numbers there. So what we do here, it's all about differences, okay? Step one. You ready? Step 1, are you writing this down? Find the first differences. Find the first differences. And now when you're hearing differences, you should be thinking subtract. So in other words, how do I turn 4 into 7? What's the difference? Well, you add 3. 7 minus 4 is a positive 3. How do I turn 7 into 10? Well, I add 3. Okay, 10 to 13, I add 3. Do you notice how this add 3 shows up every single time? These are my first differences. Yeah, the first differences. Okay, it's plus 3 every time. That's a great thing. When the first difference is always the same, if the same, the equation will be linear. The equation is linear. It's going to be a linear equation. All right, that means the highest exponent on x is going to be 1. All right, now it's even cooler when, uh-oh, I got a sneeze coming on. Remember, there's no pause, so cover your ears. Oh, excuse me. Sorry, I hope that wasn't too loud. All right, so the first difference ended up being the same. Well, what I'm going to do is I'm going to take that number there, and I'm going to multiply it by n. By the nth term, I'm going to go 3n. And then I'm going to do a comparison line. Okay? And I'm going to take these numbers here, this 1, this 2, this 3, 4, 5, and I'm going to put them in for n. So in other words, this is 3 times n, right? I'm going to do 3 times 1, and I'm going to write it there. Then I'm going to do 3 times 2 and write it there, right below the 2, see? Then 3 times 3 is 9, and 3 times 4 is 12, and 3 times 5 is 15. Now, if it matches my f of x line, I know my rule. My rule is 3n, if it matches. So I better compare. So let's compare. How do do the 3 and the 4 match? No, they don't. The 6 and 7 don't match. The 9 and 10 don't match. Oh, phooey, they're supposed to match. Hey, wait a minute. Did you notice that the blue numbers, the 3, 6, 9, 12, and 15, are all exactly 1 less than 4, 7, 10, 13, and 16? I would add 1 to each of these blue ones, right? And it would turn into those black ones, the f of x lines, the output line. Well, why don't I take this 3n and add 1 to it? Let's test it to see if it works. Oh, we should test it. Always test it. Here, I'm going to test it. Let me get color I haven't used yet, orange. All right, let me go 3 times 2 plus 1. I'm thinking that my function is going to be f of x equals 3n plus 1. F of x equals 3n plus 1. That's going to be my linear equation, okay? And you're like, what's this f of x? So that's the output. That's what, comes out after I put a number in for the function. So f of x, 3 times 2 is 6. 6 plus 1 is 7. Oh, look at that. I got a 7 right there. Better test it again. Better test it again. You don't want to test it once. Once will fool you. Better test it 3 times. If you test it 3 times, you're going to be right 99% of the time. Let's try f of 4. Okay, well, f of 4 would be 3 times 4 plus 1, right? That'll be 12 plus 1. That'll be 13. Ooh, look at that. When x was 4, f of x was 13. All right, better test it one more time. One more time. How about 5? F of 5. What is f of 5 going to be? It's going to be 3 times 5 plus 1. Well, that'll be 15 plus 1. Hot dog, it matches. Look at that. So I know I have the right function. My function, my equation is f of x equals 3n plus 1. Now, no matter what n is, I can figure out f of x in just a couple steps. So this box seems to want to know what the 50th term is. Now see, back in the 6th grade way of doing it, you would have to figure out the 6th term, the 7th term, the 8th term, all the way up to the 49th term. Then you can figure out the 50th term. To me, that is so pointless. It would drive me insane to do that. It would be such a waste of time. I'm just going to take 50 and put it into my function like this. So 3 times 50 is 150 plus 1, 151. There you go. There you go. And this is a linear function. And again, we'll define function later. We're going to really get comfortable using the words. All right, let's look at the second example. Excuse me. By the way, you guys know when I'm doing that, I'm making fun of myself. Some of you kind of look at me like, why are you making fun of me? I don't do it to you. I do it to me when I'm tripping over my own tongue because I get so excited and I go so fast. I just need to slow down, right? What does a yellow light mean? Slow down. What does a yellow light mean? Slow down. Okay, anyway, enough of that. Let's try this one. First step, find the first differences. So I'm going to find the first differences. Hey, by the way, why is this one called g of x? Because it's just a different function. That's all. This a letter of x. That's how you read that, g of x. It's just a different function. They're not all going to be f. Some will be h of x, okay? They'll all be different functions. That's okay. You're going to see lots of different letters. So I'm going to go find the first difference. It looks like it's plus 5. Looks like it's plus 5. How do I turn 12 to 17? I add 5. Or 22 minus 17 is positive 5. So it's plus 5 every time. When the first difference repeats every time, this is linear. Why is it linear? Sam, are you listening? Because the first difference is repeating. If the first difference wasn't repeating, it wouldn't be linear. We'll talk about that tomorrow, some other types of functions. But when the first difference is the same, it's linear. So I take this difference, this constant difference of 5, and I'm going to multiply it by n. I'm wondering if g of x equals 5 times x. That's what I'm wondering. I think it might be that. I'm going to plug in 1, 2, 3, 4, and 5 into this. So I'm going to do g of 1, and that's what's going to go there, and then I'll do g of 2 right here, and this will be g of 3. Oh, I got an extra parenthesis in there. Sorry about that. See if I can get that out of there without doing too much damage. Oop, that's not my eraser. Silly me. Let's see here. Oh, that's pretty good. All right, and then this one will be g of 4, and then g of 5, right? So I'm just taking these numbers, putting them into this function, and seeing if they match. Well, 5 times 1 is 5. 5 times 2 is 10. 15, 5, 10, 15, 20, 25. Stop. There we go. All right. Now, do they match? No, I don't think they do. Because 5 is not the same as 2. And 10 is not the same as 7. And 15 is not the same as 12. And 20 is not the same as 17. And 25 is not the same as 22. Maybe I better go back. Wait, I see it. Do you see it? How can I turn this blue 5 into the black 2? Well, I could subtract 3. If I take the 10 and I subtract 3, don't I get 7? 15 minus 3 is 12. 20 minus 3 is 17. And 25 minus 3 is 22. So why don't I take this 5n here, and subtract 3? So I'm thinking that g of x is really going to be 5x, or 5n, it could be 5n, minus 3. I'm treating n as a specific number. All right, well, we better test it. Let's do g of 1, figure out what that is. Let's do g of 3, and let's do g of 4. I'm picking different numbers to test it. I don't know why there's a 0 there. Sorry about that. All right, g of 1. So I'm going to go 5 times 1 minus 3, and that should be 2. Ooh, I like that. G of 3 would be 5 times 3 minus 3, and I think that'll be 7. Ooh, hot dog. All right, 5 times 4 minus 3, and that'll be 17. Oh, man, I'm on to something. I've got it. So now I can do g of 100. So g of 100, plug it into my function, it'll be 5 times 100 minus 3. Well, that'll be 500 minus 3 will be 497. So 497. There's my table filled out. My function is right here. What type of function is it? It's linear. Notice the highest power in x is 1. All right, one more example, and then we're going to wrap up this video. Step 1, find the first differences. All right, so let's see here. Do I add 4 there? No, I don't. I subtract 4, don't I? To go from -2 to -6 on a number line, I have to go 4 in the negative direction. How about to get from -6 to -10? Well, that would be -4. Some of you are going to have trouble with this. Let's do it the subtraction way. -6 minus -2. Isn't minus a negative the same as plus a positive? And a -6 plus 2 is a -4. If I did -10 minus -6, I add I get negative 4, right? In fact, it's going to be negative 4 all the way across. I'll leave that to you to verify that I'm telling the truth. All right, so what type of function is this? What's that, Kevin? It's linear, right? Very good, Kevin. It is a linear function. And I'm speculating that it might be h of x might equal negative 4n. So I'm going to do that little comparison line. Okay, notice the function had a different name. It's h of x this time. So I'm going to do h of 1 right here. And of course, h of 2, and h of 3, and h of 4, and h of 5. All right, so h of 1, negative 4 times 1 is negative 4. 4 times 2, negative 8, negative 12, negative 16, and negative 20. Now I compare. Are they the same? No, not the same. Not the same. Not the same. Oh dear, I get so frustrated. Why don't I just give up? But wait, I see it. I'm going to add 2 each time. Negative 4 plus 2 is negative 2. Negative 8 plus 2 is negative 6. Negative 12 plus 2 is negative 10. Negative 16 plus 2 is negative 14. And negative 20 plus 2 is negative 18. Oh, so that must mean I need to take this negative 4 and add 2 to it. So my function must be h of x, the same as negative 4x plus 2. Notice how this and this match. Okay? Well, I'm going to test it just to make sure. So this time I'm going to do h of 2. I'm going to do h of 3. And then I'll do h of 5. And so, negative 4 times 2 plus 2. And then negative 4 times 3 plus 2. And there it is. It matches. See the 2 there and the 2 there. They're the same. The 3 and the 3 are the same. Okay, h of 5 is negative 4 times 5 plus 2. So negative 4 times 5 is negative 20. Negative 20 plus 2, negative 18. Ooh, I like that. Negative 4 times 3 is negative 12. Negative 12 plus 2 is negative 10. Ah, dog. And negative 4 times 2 is negative 8. Plus 2 is negative 6. Negative 6. Wow. All right. So, to do, I have the right function. It's a linear function. Here's the equation right there. And now I need to do h of 1,000. Oops. Which will be negative 4 times 1,000 plus 2. So it'll be negative 4,000 plus 2, which will end up being negative 3,998. And there you go. That's what's going to go in this box right here. I don't have room to write it inside the box. The box is kind of small. All right. So I'm not going to have a video quiz on the end of this one. Hopefully you took notes. You may want to go back and watch this again. There will definitely be a video quiz tomorrow. All right, that's it for tonight. Mr. Lawrence signing off. Have a good night, everybody.